Good morning. I said good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Thank God. Okay, we'll start with the radius of curvature. This is the second part of this module, radius of curvature. Wait a minute, this pen is not working. You will be given
Good morning, sir.
ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಅಪ್ಪ. ನನ್ನ ವಾಯ್ಸ್ ನಿಮ್ಗೆ ಕೇಳ್ತಾ ಇದೆಯೋ ಇಲ್ಲೋ ಅಂತ ನಾನು ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತೀನಿ ಅಷ್ಟೇ. ನೀವು ಒಮ್ಮೆ ಮಾತಾಡ್ಬಿಟ್ರೆ ನನಗೆ ಗ್ಯಾರಂಟಿ ನೀವು ಕೇಳಿಸ್ಕೊಳ್ತಾ ಇದ್ದೀರಾ ಅಂತ, ಅದಕ್ಕೆ ಮಾತಾಡಿ ಅಂತ ಹೇಳೋದು. ಓಕೆ, ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ.
Yes, sir.
Okay, you will be given a curve like this, part of the curve like this. Here it is given, a part of the curve will be given like this. If you imagine a complete circle, taking this as part of the circle, or construct a circle considering this part as one of the part of this circle, the circle will take this shape. Then a radius of this assumed circle is called a radius of curvature, and this is the center of curvature. You will be given only a part of the circle like this. Then assume the entire circle. It will take this form. Assume the entire circle, mark its center. This is called a center of curvature. It is called a center of curvature. And the radius of this assumed circle is called a radius of curvature. This is called a radius of curvature. Here we have come across 4 kind of problems, but in our syllabus only 2 kind of problems are included. One is in Cartesian form and the other in polar form. First, I would like to solve polar form problems. Problems which are in polar form. Expression for radius of curvature in case of polar form. Expression for radius of curvature in polar form. Earlier this direction was included, but now it is excluded from the syllabus. Only expression, that is r dash square, r dash is dr by d theta plus r square whole power 3 by 2 divided by r square plus 2r dash whole square minus r into r double dash. This is to find a radius of curvature in case of polar curves. But this will take a lot of time to solve the problems. Therefore, I use this formula. This is called a radius of curvature in pedal form. This will reduce the level of difficulty. These problems are very difficult. You can solve these problems in this method also, that is in polar form method. I prefer to use this method. Rho is equal to r into dr by d theta. This is a simple formula and problems will be very simple. This is very complicated formula and simplification will be very difficult. We'll solve a problem, we'll come to know what actually these problems are. Show that for the equiangular spiral, r is equal to a into e power theta cot alpha, where both a and alpha are constants. Rho by r is a constant. Rho is radius of curvature. Radius of curvature is denoted by rho. This is a standard notation. Rho stands for radius of curvature. You keep this in mind. This rho stands for radius of curvature. Show that for the equiangular spiral, r is equal to a into e power theta cot alpha, where a is a constant, alpha is a constant, then rho by r is also a constant. That means first you have to find rho. Rho means radius of curvature. First we find pedal equation, right? To find pedal equation, what is required? Angle between radius vector and tangent is required, which is denoted by phi. That is to be determined first. R is equal to a into e power theta cot alpha. This is the given expression. Now take log on both sides. Take log on both sides. Log r is equal to log a into e power theta cot alpha. Log is applied on both sides. Therefore, log r is equal to, clearly this takes log m into n form. Log m into n is log m plus log n. That is log a plus log e power theta cot alpha. Therefore, log r is equal to log a plus log e power theta cot alpha is theta cot alpha. This is because log e power x is xx. Therefore, log e power theta cot alpha is theta cot alpha, where alpha is a constant. Therefore, cot alpha is also a constant. Now differentiate both sides with respect to theta. The derivative of log r is 1 by r and derivative of r is dr by d theta. Derivative of log r is 1 by r and derivative of r is dr by d theta. Here log a is a constant, its derivative must be 0. Here cot alpha is constant, keep it as this. Derivative of theta with respect to theta is 1. And 1 by r into dr by d theta is denoted by cot phi. Cot phi is equal to cot alpha. Therefore, phi is equal to alpha. This is angle between radius vector and tangent. Now substitute this in p is equal to r sin alpha. Substitute in p is equal to r sin alpha. And we just obtained that alpha is equal to, r sin phi. We just obtained phi is equal to alpha. Therefore, this is p is equal to r sin alpha. This is the pedal equation. Theta is eliminated. P is equal to r sin alpha. Next, we find radius of curvature. To find radius of curvature, differentiate with respect to r first. Differentiate with respect to r. Derivative of p with respect to r is p is a function of r. It is not a constant. Derivative of p with respect to r is dp by dr. This is equal to, here sin alpha is a constant, keep it as it is. Derivative of r with respect to r is 1. And required is r into dp by dr. Therefore, take the reciprocal of this. Dr by dp is equal to reciprocal of sin alpha is cosecant alpha. Multiply both sides by r. You get r into dr by dp is equal to cosecant alpha into r. Multiply both sides by r. And r into dr by dp is radius of curvature. I have given you this expression. R into dr by dp is radius of curvature. cosecant alpha is a constant. Alpha is constant, therefore cosecant alpha is a constant into R. Therefore, rho by R is a constant. Rho by R is a constant. This is what we require to prove. R into dr by dp is radius of curvature in pedal form. We use this pedal form to solve problems which are expressed in terms of polar form also. I given this expression here. Radius of curvature in pedal form is rho is equal to R into dr by dp. Show that for the curve r power n is equal to a power n sine n theta, rho varies inversely as r power n minus 1. Another problem expressed in terms of polar form. Polar form. Show that for the curve r power n is equal to a power n sine n theta, rho varies inversely as r power n minus 1. First we find pedal equation. In order to find pedal equation, we have to find phi, angle between radius vector and tangent. Take log on both sides. We get log r power n is equal to log a power n into sine n theta. Log r power n is equal to log a power n sine n theta. Clearly this takes log m into n form. Log m into n is log m plus log n. That is log a power n plus log sine n theta. And log r power n takes n log r form, because log m power n is n log m. That is a known result. Therefore, log r power n is n log r. This is equal to, for the same reason, this can also be written as n log a plus log sine n theta. We keep it as this. Now differentiate both sides with respect to theta. Here n is a constant, keep it as this. The derivative of log r is 1 by r into dr by d theta. N by r into dr by d theta is equal to n log a is a constant, its derivative must be 0. And derivative of log sine n theta is 1 over sine n theta into derivative of sine n theta is cos n theta into derivative of n theta with respect to theta is n. Therefore, n cos n theta divided by sine n theta, that can be written as n cot n theta. Cos by sine is cot. Now cancel this n with this n. 1 by r into dr by d theta is denoted by cot phi is equal to cot n theta. Therefore, phi is equal to n theta. Phi is equal to n theta. Now we substitute this result in p is equal to r sine theta. P is equal to r into sine phi and phi is equal to n theta. Substitute in p is equal to r sine phi, where phi is n theta. Therefore, we get p is equal to r sine n theta. Let this be equation number 1. You either substitute this equation in this equation or this equation in this equation. And consider r power n is equal to a power n sine n theta. And from equation number 1, sine n theta is equal to p by r. Substitute sine n theta is equal to p by r and rest same. Therefore, r into r power n is r power n plus 1. R into r power n is r power n plus 1. This is equal to a power n into p. Therefore, p is equal to r power n plus 1 divided by a power n. This is what we call pedal equation. This is the pedal equation corresponding to the given curve r power n is equal to a power n sine n theta. Now we shall find a radius of curvature. P is equal to R power n plus 1 divided by A power n. This is Pradal equation. To find radius of curvature, differentiate both sides with respect to R. Derivative of P with respect to R is dP by dr. Derivative of P is dP by dr. Here 1 over E power n is constant. We keep this constant as this. Derivative of R power n plus 1 with respect to R is n plus 1 into R power n plus 1 minus 1, that is R power n. And required is dr by dp. Therefore, take the reciprocal. Reciprocal of dp by dr is dr by dp. And reciprocal of this n plus 1 into R power n divided by A power n is A power n divided by n plus 1 into R power n. And 1 over R power n can also be written as R power minus n. R power minus n. Now multiply both sides by R. Because required is R into dr by dp. Therefore, multiply both sides by R. R into dr by dp is equal to A power n divided by n plus 1. R into R power minus n is R into R power minus n is R power at the power, that is minus n plus 1. Minus n plus 1. This is equal to A power n divided by n plus 1. R power minus n plus 1 can also be written as 1 divided by R power. As this term comes to the denominator, sign of the index changes. Minus n will be plus n and plus 1 will be minus 1. Therefore, R into dr by dp is denoted by rho. It is radius of curvature. This is equal to A power n divided by n plus 1 into 1 divided by R power n plus 1. And A power n divided by n plus 1 is a constant. Therefore, this is equal to constant into 1 over n minus 1. Now you remove this constant and put a proportionality sign. P is proportional to, directly proportional to 1 divided by R minus 1. Or you can read it as P is inversely proportional to R power n minus 1. P is directly proportional to 1 over R power n minus 1. Or P is inversely proportional to R power n minus 1. This is what we require. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, you make a note of this. Good, sir. We'll move on to next problem. Show that the radius of curvature of the curve R power n is equal to A power n cos n theta varies inversely as R power n minus 1. Almost same kind of problem. First we find Pradal equation. First we find Pradal equation corresponding to R power n is equal to A power n cos n theta. Take log on both sides. Take log on both sides. Log R power n is equal to log A power n cos n theta. Clearly this takes log m into n form. This is m and this is n, that can be written as log m plus log n. That is log A power n plus log cos n theta. Log R power n, it takes log m power n form, that can be written as n log A. For the same reason, this can be written as n log A plus log cos n theta as it is. Now differentiate both sides with respect to theta. Differentiate both sides with respect to theta. Here n is a constant, keep it as it is. Derivative of log r is 1 by r into dr by d theta. N is a constant, keep that constant as this. Derivative of log r is 1 by r dr by d theta. Here n log a is a constant, its derivative must be 0. Derivative of log cos n theta is 1 over cos n theta into derivative of cos n theta is minus sin n theta, and the derivative of n theta is n. Substitute. Derivative of log cos n theta is 1 over cos n theta, and derivative of cos n theta is minus sin n theta, and derivative of this n theta with respect to theta is n. Here n is common in both the terms. Divide the equation throughout by n. 1 by r into dr by d theta is denoted by cot phi. This is equal to minus sin n theta divided by cos n theta is tan n theta. Now this is to be converted into cot. We know that cot pi by 2 plus theta. Cot pi by 2 plus theta is equal to minus tan theta, or minus tan theta is equal to cot pi by 2 plus theta. Therefore, this minus tan n theta is equal to cot pi by 2 plus theta is n theta. Therefore, phi is equal to pi by 2 plus n theta. Now, substitute this in p is equal to r sin phi to find Padal equation. Substitute in p is equal to r sin phi. This is phi, r sin phi. Substitute in p is equal to r sin phi. R into sin phi, and phi is pi by 2 plus n theta. Sin pi by 2 is odd multiple of 90 degrees. Therefore, sin changes into cos, and angle is n theta, or cos n theta. Pi by 2 plus n theta lies in second quadrant, and in second quadrant sin is positive. Therefore, p is equal to r cos n theta. Let this be equation number 1. Equation number 1. Now consider the given equation, that is r power n is equal to a power n cos n theta. Therefore, r power n is equal to a power n cos n theta. From equation number 1, cos n theta is p by r. Substitute. This is p by r. Therefore, r into r power n is r power n plus 1 is equal to a power n into p. This is what we call Padal equation. R power n into p is equal to r power n plus 1. Padal equation. Now we shall find a radius of curvature. To find radius of curvature, differentiate the Padal equation with respect to r. Differentiate with respect to r. Here a power n is a constant, keep it as it is. Derivative of p with respect to r is denoted by dp by dr. Is equal to derivative of r power n plus 1 with respect to r is n plus 1 into r power n plus 1 minus 1. Derivative of this term is n plus 1 into r power n plus 1 minus 1. Therefore, this is n plus 1 into r power, cancel this plus 1 with this minus 1, r power n. N plus 1 into r power n. Therefore, dp by dr is equal to LHS. This one. dp by dr is equal to n plus 1 into r power n divided by a power n. And required is dr by dp. Therefore, take the reciprocal of this. Reciprocal of dp by dr is dr by dp. And here, a power n divided by n plus 1 into 1 over r power n. Interchange numerator into denominator and denominator into numerator. Now multiply both sides by r. R into dr by dp is equal to, r into dr by dp is equal to a power n divided by n plus 1 into r divided by r power n. Multiply both sides by n. This is simple. R into dr by dp. If you multiply this RHS by r, you get a power n divided by n plus 1 into 1 over r power n into r. Correct? And a power n divided by n plus 1. You keep this as is into 1 divided by r divided by r power n can be written as r power n minus 1. That's what I have written here. 1 divided by r power n minus 1. And r into dr by dp is denoted by rho. A power n divided by n plus 1 into 1 divided by r power n minus 1. This is equal to a power n is a constant, n plus 1 is a constant. Therefore, this entire ratio is a constant. Constant into 1 divided by r power n minus 1. Now remove this constant and put a proportionality sign. R is directly proportional to 1 over r power n minus 1, or you can read it as R is inversely proportional to r power n minus 1. Is this clear?
Yes, sir.
Yes, sir.
Fine. You note on this problem. These are very important. You can expect a problem of this kind in examination. 100%. You put your attendance in the chat box. I'll enable it now. It's over. Let's take up one more problem. Show that for the curve r square secant 2 theta is equal to a square, rho is equal to a square divided by 3r. Show that for the curve r square secant 2 theta is equal to a square, radius of curvature is a square divided by 3r. First we shall find phi. Take log on both sides. Log r square secant 2 theta is equal to log a square. Take log on both sides. Now it takes log m into n power. That can be written as log m plus log n. Log r square plus log secant 2 theta is equal to log a square. And log r square can also be written as 2 log r plus log secant 2 theta is equal to log a square can be written as 2 log a, because log m power n is n log m. Now differentiate both sides with respect to theta. Here 2 is a constant, keep it as it is. Derivative of log r is 1 by r into dr by dt. Dr by d theta. Derivative of log secant 2 theta is 1 over secant 2 theta. And the derivative of secant 2 theta is secant 2 theta into tan 2 theta. Into derivative of 2 theta with respect to theta is 2. This is equal to 2 log a is a constant. Its derivative must be 0. Here 2 is common in both the terms, so divide the equation throughout by 2. Cancel this secant 2 theta with this secant 2 theta. And 1 by r into dr by d theta is denoted by cot phi. What is left here? Tan 2 theta. Transform this to RHS, sign changes, and it becomes minus tan 2 theta. And we know that cot pi by 2 plus theta, cot pi by 2 plus theta is equal to minus tan theta. Use this expression. Therefore, minus tan theta is equal to cot pi by 2 plus theta. Minus tan theta is equal to cot pi by 2 plus theta. Here theta is 2 theta. Therefore, phi is equal to pi by 2 plus 2 theta. Now substituting P is equal to R sin phi. Therefore, this is equal to R into sin phi, and phi is pi by 2 plus 2 theta. Since this is odd multiple of pi by 2, 1 into pi by 2, odd multiple of pi by 2, sin changes into cos and angle is 2 theta and it lies in first quadrant. Pi by 2 plus theta lies in first quadrant. Therefore, sin is positive. P is equal to R into cos 2 theta. Let this be equation number 1. Since R square into secant 2 theta is equal to A square, R square into secant 2 theta is equal to A square. This is given expression. Substitute secant 2 theta. Here cos 2 theta is equal to P by R. From equation number 1, cos 2 theta is P by R. And its reciprocal secant 2 theta is equal to R by P. Substitute. Secant 2 theta is R by P is equal to A square. R square into R cube is equal to P into A square. A square. This is the Pradal equation. Pradal equation of this given curve R square secant 2 theta is equal to A square. A square P is equal to R cube. Now differentiate both sides with respect to R. To find radius of curvature, differentiate both sides with respect to R. Here A square is a constant. Derivative of P is dP by dr is equal to derivative of R cube is 3R square. Mute your audio. A square into derivative of P is dP by dr. This is equal to derivative of R cube is 3R square. Therefore, dP by dr is equal to 3R square divided by A square. 3R square divided by A square. But required is dr by dP. Therefore, we shall take the reciprocal. The reciprocal of dP by dr is dr by dP. This is equal to A square divided by 3R square. Interchange numerator into denominator and denominator into numerator. Now multiply both sides by R. R into dr by dP. R into dr by dP is equal to A square divided by 3R square into R. Cancel 1R with 1R here. You get A square divided by 3R. And R into dr by dP is denoted by rho. Rho is equal to A square divided by 3R. Therefore, rho is equal to A square divided by 3 is a constant into 1 by R. Now, remove this constant and put a proportionality sign. Rho is directly proportional to 1 by R, or you can call it as rho is inversely proportional to R. Rho square is equal to A square divided by 3R. This is enough here. This is required. Rho is equal to A square divided by 3R. Yes, A square divided by 3R. Are you the problem, so?
Yes, sir.
Okay.
Sir,
Yes, sir.
You note down this problem and try this one by yourselves at your home. Anyway, I will discuss this problem in the next class. You note down this R into 1 minus cos theta is equal to 2A. Show that rho square varies as R cube. This will be terminated within 1 minute. We are running out of the time.